All right, day 9 here. We're going to start section 5.6. We did skip section 5.5. So if that's something that's popping in your head, you did not miss anything. We are going from 5.4, skipping 5.5, and moving on to 5.6. And 5.6 is going to kind of tone things down a little bit when it comes to complexity of things that we're trying to understand. Some things we might already know, but we're just going to put some finishing touches on them and formalize some of these things. So the first thing we're going to talk about is the comparison property of inequalities or of inequality. So basically, we're going to be comparing in triangles how three angles compare to each other and how the three sides compare to each other. So if A equals B with a little help of plus C. So two things are getting added together to equal A. And if that thing that's added to B is positive, so it's not zero, it's not negative, it's actually going to add on to B. It's going to make B bigger. That means that A had to originally be bigger than B. If you think about that, if you're going to add something to B to then make it equal to A, that means B had to be less than A to begin with. So A is greater than B. And right off the bat, we have a corollary to that. So this corollary is going to build off of the exterior angle theorem. So the measure of an exterior angle of a triangle is greater than the measure of each of its remote interior angles. So let's read that one more time. The measure of an exterior angle is greater than the measure of each of its remote interior angles. So we're going to use this idea along with the exterior angle theorem. Now remember, the exterior angle theorem says that angle 1 equals angle 2 plus angle 3. So we're just saying that if we were to take one of these angles on their own, angle 1 has to be greater than each of these on its own if it takes both of them added together just to go ahead and equal angle 1. So that means angle 1 is greater than angle 2. Angle 1 is greater than angle 3. All right, use the figure at the right. Why is the measure of angle 2 greater than the measure of angle 3? So the measure of angle 2 greater than the measure of angle 3. So we have something missing here. It's not showing up on the copy. So this triangle is an isosceles triangle, which means that angle 1 and angle 2 are congruent. So we can write this out. Measure of angle 1 equals the measure of angle 2. They're base angles. So that's the isosceles triangle theorem. Also, angle 1, right here at B, is an exterior angle to triangle ABD. So using the corollary above, we can say that measure of angle 1 is greater than the measure of angle 3. Using the substitution method, we can therefore say that the measure of angle 2 is greater than the measure of angle 3. So this is because it was an isosceles triangle. This is the corollary above because angle 1 is exterior. So angle 1 is exterior to this triangle over here. Okay? 2 is not exterior, but 1 is. And then substitution method, we're bringing this and substituting it in down here. All right, so the next one here. Using the same figure, y is the measure of angle 5 greater than the measure of angle C. And for this, you really kind of have to take a step back and look at the different triangles we have going on here. This time we're going to look at this biggest triangle and see that angle 5 is an exterior angle to that blue triangle, which would mean C is an interior angle. So angle 5 is an exterior. To triangle ACD, and angle C is let's be more specific, a remote interior angle. And so that satisfies the corollary above. All right, theorem 510. If two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. Then the larger angle lies opposite the longer side. So if XZ is greater than XY, that means angle Y is going to be greater than the measure of angle Z. So basically we're talking about if it's a non-isosceles triangle. We don't want it to be an isosceles triangle right there, or else we'd have two congruent base angles, so we'd have a tie essentially. So there's a relationship between longer sides and opposite angles. Okay? The longer the side, the bigger the opposite angle. That angle has to open up wider in order to create that long side. A town park is triangular. A landscape architect wants to place a bench at the corner with the largest angle. Which two streets form the corner with the largest angle? Since neither of the sides are congruent, okay, we can say that the largest angle is going to correlate opposite to the longer side. So MLK Boulevard and Valley Road. All right, theorem 511. If two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. The longer side lies opposite the larger angle. So if the measure of angle A is greater than the measure of angle B, then BC is going to be greater than AC. BC and AC. So look at that idea of that opposite sides. List the sides in order from shortest to longest. So right now we only see two angles. So we can distinguish between those two. But we also have one that is missing. Since all the angles of a triangle should add up to 180, that means T is going to equal 60. So we have 58 goes with TV, 62 goes with TU, and 60 goes with UV. So let's pay attention. Shortest to longest, and they're talking about sides. So it's going to be TV is less than UV, which is less than TU. All right, in the figure at the right, measure of angle S is 24. O is 103. I'm sorry, 130. Which side of triangle SOX is the shortest? Explain your reasoning. So we'll talk this reasoning out. We have the triangle angle sum theorem. So this is going to be 180 minus 130, so that's 50, minus 24, that's 26 degrees. So that means this is our smallest angle, therefore OX is our smallest side. Since the measure of angle 24, the measure of angle S is the smallest, Then the opposite side OX is the shortest. All right, Theorem 512, triangle inequality theorem. The sum of the lengths of any two sides is greater than the length of the third side. So take any two sides, add them up, it needs to be bigger than that third side. So if I add up x, y, and y, z, that sum has to be bigger than x, z. So x, y plus y, z has to be greater than xz. And we can flip that around. xy plus xz has to be greater than yz. xz plus yz has to be greater than xy. So can a triangle have sides with the given lengths? So I'm going to basically try those three scenarios. 3 plus 7 is greater than 8, so that's good. 3 plus 8 is greater than 7. Those are bad greater than symbols. And then 7 plus 8 is greater than 3. So all three of those need to work out. So yes, a triangle can have those three. Let's look at this one. We have 5 plus 10 is not equal to 15. I'm sorry, not greater than 15. It's equal to. So no good. So we can stop right there. So we don't want it to be equal to. We want it to be greater than. All right, so we're going to try 2 plus 6. Is it greater than 9? No. Down here. 4 plus 6, is it greater than 9? Yes. Is 4 plus 9 greater than 6? Yes. Is 9 plus 6 greater than 4? Yes. So B is good, A up top is not good. All right, two sides of a sandbox are 5 feet and 8 feet long. Apparently this is a triangular sandbox. What is the range of possible lengths for the third side? So 5, 8, and x. So 5 plus 8 has to be greater than x. That's one scenario. 5 plus x has to be greater than 8. And then x plus 8 has to be greater than 5. So we have 3 simple inequalities to solve. So 13 has to be greater than x, or we can flip that around and say x has to be less than 13. Here, if I subtract 5 from both sides, x has to be greater than 3. Subtract 8 from both sides, x has to be greater than negative 3. So when we look at the 3 options we have here, we have one upper limit. We know x cannot be above 13. But for a lower limit, it's saying that x has to be above negative 3. So a side length can't be negative 3, negative 2, negative 1, or 0. But can the side length be 1? That satisfies over here, but it doesn't satisfy here. So basically, this is the best that we can do. It has to be above 3. If it's above 3, it satisfies over here. Okay, so these are the two that we're going to select. So our answer is going to be x is going to be between 3 and 13 as a compound inequality. And let's look at this bottom one here. So we have 4 plus 7 has to be greater than x. 4 plus x has to be greater than 7. And then x plus 7 has to be greater than 4. So 11 has to be greater than x. I like to flip that around and say x is less than 11. Subtract the 4. X has to be greater than 3. X has to be greater than negative 3. We're going to take these two. So x is going to be between 3 and 11. All right, make sure you guys practice that homework. This is the last section of chapter 5. Make sure you guys are practicing the homework. You're asking me questions. You have a homework quiz that you should have hopefully done already. If not, make sure you do the homework quiz for the previous sections. We'll have a live review on Monday. Make sure you guys are asking questions then and get ready for the test come Tuesday.